Let's go ahead and take a few examples of more complicated manifestations of the closure so that we can clear up any misconceptions that we have about closures. So, with this code on line 15, we declare that the variable x is assigned to the value 10. Then we see a function definition. Right now, we don't do anything with this, so we skip over it. And line 25, we see that we declare another variable called result that is assigned the value of some function outer being invoked. Okay, we know it's being invoked because of the invocation parentheses. So let's go and find outer. We have to look up in our code for it. All right, we see it on line 17. If you invoke outer, which is what we're doing right now, we start looking through this definition. Now we care what's inside. We see that in outer, we initialize a variable x, which is assigned the value of the number 20. Now, what's interesting about this is x in the outer scope was assigned the value of the number 10. But here, when we declare another variable, we are actually doing something called shadowing the outer variable. So this variable x in this scope defined on line 18 and within this function is going to have the value of 20, not 10. Now, we see that we define another function within our current function outer, and this function is called inner, which is aptly named. We're going to skip over this definition, right? Because we're not invoking it yet. Finally, on line 22, we return inner, invoked. Okay, so whatever invoking inner to, whatever value inner evaluates to when it's invoked, that's what we're going to return ultimately from this function outer. So now we have to go look at inner and what it does. So we return to the function definition for inner. It doesn't take any parameters, which would be inside of these parentheses. And we see that we return a variable x. So in order to know what value x is, JavaScript, remember, stores the lexical environment of any function whenever it's created. So for instance, when we skipped over this definition of inner, this was actually assigned inner. The word inner was assigned the value of this function. And also it was assigned the lexical scope that it exists in, that inner exists in, which in this case has x being assigned the value of 20 because it's the immediate closest value of x, not the global scope x. So we return 20. That's what inner returns. And we look here, and we're returning whatever was the evaluated, whatever was evaluated from invoking inner, which in this case is 20, like we said. Awesome. That is what our outer function returns. So we actually expect result here to be 20 because outer being invoked returns inner being invoked, which returns x, which has the value of 20 being set from outer. Okay, cool. Let's just check this out. We'll have to see what the value of result is. We jump through this really fast because we already have talked about it. Let's see here. Let's bring this down. Here you go. You can see that result has the value of 20. Now, interestingly, you can see that x, as in the x on line 15, still has the value of 10. The x declared inside the function outer did not affect the x on line 15. That's because the keyword var is function scoped, meaning that it influences everything inside of this function, the function curly brackets, but outside of it, the x is unchanged. So interestingly, when we're returning x from inner, we're actually returning this x from line 18 and not the same variable x from line 15, which can be a little bit confusing, but we return 20 is the immediate result. Awesome. So that's a little bit of closure, a little bit of scopes, but scopes and closures really are intertwined and kind of adjacent to each other. They're not the same thing, but you really have to understand scopes to fully grasp closures as well. Okay, let's go ahead and try some more. Let's try another example here. And what is that example? It is, I'm going to copy and paste some code here. Awesome. All right. Cool. So, what do we have? On line 15, once again, we're declaring our faithful variable x equal to the number 30. Next, we have a couple function definitions. These functions aren't being invoked, so we don't even really need to look at the definition right now. We just skip over it. Next, on line 20, we see that we're invoking some function that's called set. We know we're invoking it because of the invocation parentheses. And we're passing an argument of number 10 to this set function. So now we have to go, set could be way, way higher up in our code, but we got to find where it is. Happily for us, it's on line 18, it's right above. So here we have the definition for set. We would pass in the value 10, and that's because we're invoking it with 10. And what are we doing inside of set? Well, we are saying that the variable x is equal to value. So in this case, it will be x equal to 10, the number 10. Now we have to ask ourselves, where is x? Because we haven't declared it here. Like you have to, well, you actually don't have to declare a variable with var, but let's for all intents and purposes say that that is how we declare variables, right? We have to look for where we declared x with var. It's in the outer scope here. So we actually do have it available. Remember, inner scopes have access to outer scope variables. So inside of this function, we're saying x is equal to value, and value was 10. So inside of set, x is equal to the value of 10. But like we discussed before, this value, when we set x here, is actually not going to change the value of x outside of the function. And actually, now that I say that, I'm not entirely convinced. Let's just try it and see what happens. Okay, so here we have set. We're invoking it with the value 10, and it looks for the definition. So right now, if we look for, let's watch a variable. If we look for x, we can see that x has the value of 30 before we do anything to it. It has the value of 30 because we have access to this number 30 inside our scope. Now, when we run through that function's code, we see that x now has the value of 10. That's what we expected inside of this function, that it has the value of 10. But now I'm wondering, when we exit this function, is this x from line 15, is that same variable? Will it now have the value of 10? I'm actually thinking the answer is yes, because we didn't declare a new variable x here. We're just resetting, we're changing the assignment of what x in the higher scope is equal to. So I am going back on what I said previously. This definitely does change the value from 30 to 10. Cool. Now what's going to happen? I'm gonna stop this for a second because it just throws a lot of noise at us. That's what happens with set. It actually changes the value of x to 10. Now we have another variable we're actually declaring called result. Result is equal to whatever get invoked with the number 20 is evaluating to. So you kind of have to go this step by step. You've got a result, variable. It's called result. And now you have to see, okay, there's some function called get. Well, we hope there is, or else this will throw an error. And we've got to find the definition of get, and we've got to pass the number 20 as the first and only argument of it. So let's go find it. Thankfully, it's on line 17, very close by. Get takes one argument, which we're expecting, and here get takes in 20. The interesting thing is that we are naming the argument x. That is, I don't like how I worded that. It's actually not an argument. When we pass the 20 here, this is an argument in the invocation parentheses. But inside of the function definition parentheses, this is actually called a parameter. So we're declaring a parameter called x. Let's put it that way. What that effectively does is it creates a variable named x. Let that sink in for a second. It's basically like creating a variable named x, basically like doing this again inside of our function. So we are declaring a new variable called x, where we return the value of that variable. So kind of like in the last example, this is called shadowing, variable shadowing, where we have the name of one variable that shadows another. It goes in front of it. So now if we pass in 20 as x, we're going to return 20, not 30, because the x here creates a new variable and shadows our variable from line 15. So just to check how that works, let's put a breakpoint here. And we jump inside our get function, and you can see that x is now 20 because it was passed in as an argument, and we return the number 20. Awesome. So that's a little bit of variable shadowing. How much of closures is this? Well, I guess every time you declare a variable, every time you declare a function, you are creating a closure. You're creating a closure because now the get function has access whenever you use it to its entire lexical scope, which in this case includes the number 30, but of course we shadow 30 because we create another variable x that has the same name as the one on 15. Awesome. Let's do some more examples here. Pause that. And what's next? All right. This is one of my favorite ones. My absolute favorite ones. Let's throw this down here. Did it change anything? I don't think it did. I'm going to have to make my screen a little bit smaller so we can see all of it. Is that going to work? Almost. There we go. Okay, great. So on line 15, there's a lot of stuff going on here. So let's just walk through it line by line. This is what happens when you first run your code. Line 15, we declare a variable a equal to the value of the number 0. Same thing here on line 16. Instead, it's a variable b with a value of 0. Next, on line 18 through 26, we've got a function definition. So we don't actually need to pay attention to this right now because it isn't being invoked yet. Finally, or next, on line 28, here's where something interesting happens. We're declaring another variable called myIncrementerX. Okay, fine. MyIncrementerX is being assigned the value of whatever is returned by invoking makeIncrementer. Awesome. Let's go look at makeIncrementer. We got to go find it. It's up on line 18. So what does makeIncrementer do? Well, makeIncrementer declares a variable c. This is a function scoped variable c equal to the value of 0. Next, we increment the global variable a by 1. So actually, when we invoke makeIncrementer here on line 28, we are actually incrementing this. So a, after this invocation, will have the value of 1 because 0 plus 1 is 1. Next, we see that we are returning a function. And actually, since this function is not being invoked, we we kind of skip over this. We don't do anything that's inside this function because it's not being run yet. So the value that make incrementer returns that it evaluates to when it's invoked here on line 28 is actually this function. All right, sweet. So what does that mean? It means that my incrementer x is literally equal to this. So how would that look? It's kind of like we did something like this. Var my incrementer x is equal to that. That's kind of what we're doing here. Is we're basically saying my incrementer x is equal to this function. Now, hold it right there. Hold it right there. There is a difference between what I wrote here and what is here. And the difference is that what's actually happening on line 33 when we declare a variable my incrementer x, not only is it storing this function code, remember a closure stores the lexical environment in which it is created. So actually, we're missing something here if we just have 27 through 31. We can't, this is not the only thing that we can have in order to make my incrementer x be the same as what we're doing on line 33. What we're missing is this. Var c is 0, and yeah, sure, the a plus equals 1, but we'll see that this doesn't have as much of effect here. You'll see what I mean by that in a second. So let's make our new line. There we go. So now my incrementer x is this entire function inside of this lexical scope that actually includes the global scope too. So in this point in time, we declared a variable c is 0, right? Okay, what happens next? We're enclosing that function on line 28 as another variable. Line 29 and line 30 are both using this variable that we just created. We can store functions as values, and that's exactly what happens here. My incrementer x is this value, this function in its lexical environment. So what happens when we invoke my incrementer x? Well, we got to go look at that function. I mean, technically we're invoking it and then we're looking here to see what variable it is. Like, hey, where is my incrementer x? Well, it's on line 28. And then what's on line 28? What is that equal to? Well, it's equal to invoking make incrementer. So invoking make incrementer actually with another set of invocation parentheses. That's a little bit, maybe a little bit confusing the way I worded that, but it's kind of like doing this. Let's see. That's what's happening on line 29. So we go here and we say, hey, now we're invoking this function on line 29. We are incrementing b by 1. We are incrementing c. B is a global variable, so that's actually going to influence this global variable. But we invoke c plus equals 1, and we actually return c. So c was 0. We now add 1 to it. Great. That's all that happens in make incrementer x. Again, we invoke it on line 30. We look back again, and we find that this is our function. It's still in the same lexical environment that was created before. But this is the key. The variable c is not being reset to 0. The variable c is actually stored in that lexical environment. So we incremented it to 1 on line 29. It is actually equal, c is equal to the value of 1 on line 30 when we invoke make incrementer x, which increments b by 1, and it increments c by 1 again, so now c is equal to 2. So we incremented c here, and we incremented c here. If this doesn't make sense to you right now, try just running through this code yourself a couple of times and try to just basically, I think what brings it together for me, because this is definitely confusing, what brings it together for me is that we're not reassigning c to be 0. And the way that I know that I can kind of remind myself that, is that make incrementer it's only invoked once. And that is when we set the variable c to be equal to 0. If we invoke make incrementer again, it's going to create a new lexical environment. But we haven't done that. We're just invoking this function that was returned, and we're invoking it twice. So C actually does increment from 0 to 1 to 2. Awesome. That may take a little while to sink in. Let's look at line 32 here. Line 32 is very similar to 28 through 30, except we're making another variable that is equal to whatever is returned by make incrementer. This should seem very familiar because we just did it. But now it creates a new lexical environment, just like I was saying. So now in this environment, and by this I mean line 32, in line 32's lexical environment, my incrementer y, C is 0. Now, maybe don't worry about A, because A is a global variable. It's been incremented a few times now. In fact, it was incremented, let's see, here it was incremented, no, it wasn't incremented here because that was inside of the return function. But here, A is going to be incremented and C is 0. So now C in this function will be 1 because we increment it, 2, and then 3. Okay. So we have a lexical environment from line 28 to 30, and we have an entirely different one. These are two different closures that are happening because we're enclosing this function that's returned from make incrementer. We're enclosing it two different times. So they are different lexical environments. So next, what happens after all of these invocations is on line 37, we declare a result1, a variable called result1. That is equal to, we're assigning it the value of whatever is returned by my incrementer x. So now we go look at my incrementer x. It's this lexical environment. It's the one where C started as 0. We incremented C once, so it became 1, and then 2. And then, because we're invoking my incrementer x again, C becomes 3. And finally, we return C. So what's eventually returned by this function, my incrementer x, being invoked, result1 should be 3. Now, I ran through a lot of stuff there. Let's actually see if that's what result1 actually evaluates to. Let's see if it evaluates to 3. 1, 2, 3. All right. So I'm going to start here. All right. So first, we create this lexical environment. I'm just running through this because we've already talked about this code. My incrementer x is equal to that function on line 21. We invoke my incrementer x. Let's see. Let's actually watch the value of C here. So C is 0 so far. Remember, it starts as 0 from line 19, but we're about to increment it. Now C is 1. We return it. We don't do anything with the return value yet. Next, on line 30, we invoke it again. You can see that when we went back into this function, because we had that lexical environment stored, C is still 1. It's not 0. It's been incremented once already. So we increment it again and return it. Next, we go through my incrementer y, which when we go in here, we're expecting C to be 0 because it's declared on line 19, and this is a new lexical environment. Yep, there it is. C is 0. We keep incrementing A, that's fine. We return a function, and my incrementer y, we invoke this, and we see here, C gets invoked. It was 0, now it's 1. Now it's 2. Finally, my incrementer y again. Now it's 3. Cool. Now is where we really want to pay attention. So we're invoking my incrementer x and seeing what this return value is. Here we go. C was 2 because we had only invoked it twice. We only incremented it twice is what I mean. Now we increment C again and it becomes 3. We return the value of C, which is what result1 evaluates to. All right, man, oh my gosh, that's so much stuff to follow. If it doesn't make sense to you now, that's totally understandable. There's so much stuff happening with the scopes and storing functions as values. It's kind of a weird concept. But keep running this code line by line. This is how I understand it. This is how I do it. I go really, really slow, if you haven't noticed from the pace of this video. But you will get it. You just have to walk through it and talk to yourself out loud like I'm doing. So let's just see result 2. Result 2 is my incrementer y. We keep incrementing b and c in that lexical environment. But b is a global variable, so it actually does influence this global b, which, 7. Oh my gosh, b has been incremented a lot. Result 3 is equal to a, which looks like a was only incremented twice. Interesting, because that makes sense, because we've only invoked make incrementer twice. Look at that. It's only been invoked twice. The other times we're actually invoking the function that is returned by make incrementer. So a has only been incremented twice on line 20. Next, result 4, b is 7. Why is it such a large number? Well, it's because it has been incremented every single time that we invoke the function that's returned by make incrementer. Okay, so for instance, I know I said that these two lexical environments are different, right? But if these two lexical environments share a lexical environment, which in this case they do, the global scope is shared by both of them. So b actually increments every single time you invoke this function. So it goes from 0 to 1 to 2 to 3 to 4 to 5 to 6, finally to 7. And that's where we get the value of b equaling 7. And there's a lot of text on my screen right now. You could probably look a couple of places to see it, but here you can see b is 7. Reading the VS Code debugger is a skill unto itself that just takes practice. Let's see, is there anything else here? I'm looking through my examples that I have. I think I might have one or two more. We're going quite a long time here, but this is hopefully worth it for you. I hope this makes sense. I hope it's understandable. Remember, if not, just go over it yourself and talk to yourself about it. Talk to your inner rubber ducky, or actually get a rubber ducky, either way, right? Let's see. I'm going to paste some more code here. Oh, some shorter code. I'm so happy that we have this. The question here is, how could someone get the value of c outside of this function? So remember a long time ago in one of the previous video, I talked about how you can use multiple invocation parentheses. We're going to use that right now. So we are not invoking make incrementer. So nothing is happening. We definitely can't get the value of c if we're not invoking it. Because remember, reading from top to bottom, we have to just skip over this function definition until it's invoked. Let's invoke it now. Make incrementer. So if we invoke make incrementer, what happens? Well, we go and look at the definition. It doesn't take any, it doesn't have any parameters, but it does declare a variable c equals 0. This is only available within the scope of make incrementer. Make incrementer returns another function. Okay, so here's our closure. Here's our functions, our first class citizens deal. So the problem is that if we just invoke make incrementer, it returns a function. It doesn't return a value. I'm thinking to myself there. Nope, it does return a value because we're saying that functions are values. But this function is not being invoked. So make incrementer, when we invoke it like this on line 23, it's just equal to this function. And remember, it's equal to this function bundled with, enclosed with, its own lexical scope, which has c as 0, and any other global variables that could exist. So what we really have to do is we have to make another variable. Maybe let's call it get c. And get c is equal to make incrementer. That's our get c is actually this function. The way that we would obtain the value of c, we see that it's actually returned by our function, which is great, because otherwise we wouldn't be able to get it. We need to invoke c like that. And now we'll be able to get the value of C. So starting here, make incrementer sets C as 0, returns a function, get C is invoked, C is incremented by 1, so it becomes 1, and we return 1. Awesome. Now, you may have also noticed that there's another way to do this, which would be this. I'll show you. Remember these guys? This looks kind of funny, but we're basically just invoking whatever is returned by invoking make incrementer. Okay, that's a mouthful. Make incrementer returns a function, and we invoke it, which returns C. That's how we can get the value of C. All right, next. And I think this is our last one. But thank you for bearing with me. This is such a long video, but I hope that it makes just a little bit of sense. Hopefully it illuminates something for you. Finally, we have this code set up for us. We need to know what line 26 returns when we invoke the function bar with 2. We always start at the top. Start at the top, read the code, and see what it is. How would the JavaScript engine interpret this? Starting on line 15, we're declaring a function add. Remember that this actually kind of creates a variable called add, and that variable is equal to whatever's inside this function. Anyway, we skip the definition because we're not invoking it. We go to line 21 with a variable foo that is set to the result of whatever is returned by invoking add with a argument, the number 1. Okay, let's go look at add now. The parameter x is now going to be set the value of 1. And add itself just returns another function. So foo ends up being the value of this function where it has a lexical environment where there's a variable x that is equal to 1. Okay, so foo is this function. Then we see on the next line, but you also notice that foo is not invoked, so we don't invoke this function yet. Line 22, we have bar, a variable bar that's set to whatever is returned by invoking add with the number 3. Okay, great. So now we basically are creating another lexical environment with from add with whatever is returned by add, which we know now is this function. And now in bar's lexical environment, x is 3. Great. Next on line 24, we invoke foo with the number 3. Foo, we've got to go look and find where this was declared. It's on line 21. So foo is equal to this function where x was 1, if you remember. If we invoke foo with 3, that means that y becomes 3. So we return x plus y, which is 1 plus 3. That should return 4 on line 24. Line 26, we're invoking bar with 2. We've got to find bar. Okay, there it is. It's this closure that was created. And the 2 here refers to the parameter y. So y is equal to 2. And we said that bar comes from this line where the x in this lexical scope was 3. So 3 plus 2 is 5. So I think that bar on line 26 should return 5. Let's see what happens. So we step through this and we see foo, okay, foo returns this function, great. Bar returns this function where x is given the value of 3. Awesome. Now we see that we invoke foo, all right? Now we have to invoke this function. So x is 1 in this environment, right? And 3 is y, so 1 plus 3 is 4. The return value is 4. That's what we expected. Beautiful. Next, we have bar. Bar, the x in this example, in this lexical environment, is 3. So the y is 2. We add 3 and 2, which gives us 5. And that's what we expected to see. So just another quick example of a closure variable, of closure variables being used. And actually there are, How many closures are here actually? This is a closure. Anytime you define a function, you're creating a closure. So we have a closure here on line 15. We also have a closure on line 21 and on line 22. So that's 3 so far. And here we're just invoking functions. So I would say that there are 3 closures in this example. All right. Thanks for sticking with me. That was a lot, but I hope that closures are at least partially illuminated for you. If you stuck it this far, awesome, great job. I highly recommend just practicing these yourselves. Practice them in VS Code, practice them in Run.js, and just step through the code. Just step through, check out what each variable equals at each step of the process and see if it is what you thought it would be. That is closures. I hope you have an awesome day.